Okay, this is what I call a slow motion video covering a topic which is graphing a rational function. Okay, first of all, the word rational comes from the word ratio, and the word ratio means like a fraction. So you can kind of see why this is a rational function because it looks like a fraction or a ratio, right? Okay, first thing you need to know about graphing any kind of function is what I call old-fashioned graphing. Whenever you guys go up to advanced math, you forget everything you learned about graphing all of a sudden. You don't realize that actually you know how to graph any function. What you're learning in advanced math are tricks, shortcuts to graphing functions, so that you don't have to do it the old-fashioned way. But you can always do it in the old-fashioned way as long as you have unlimited time. Okay, so I'm going to show you how we're going to graph this function the old-fashioned way, and it's going to take a while. That's why I call this a slow motion video. The old-fashioned way is to draw a table. The table is going to have x on the left, y on the right. Normally, I like to use some strategic values of x to graph. Usually, I always use the most strategic value, which is 0. Why do I use 0? Because 0 is a good number. If you multiply by 0, it becomes 0. If you add 0, you don't have to add anything. Can you see how easy the math is with 0? So then normally, I also do the numbers around 0. -2, -1, 0, 1, 2. And then after that, you might do some numbers that are farther away. But why don't we start with these, okay, before we make life more difficult for ourselves. Guess where you're going to put the x values in to your equation to see what the y values are. Yep, you guessed right. You're going to put them here and here, right? So let's put the first value in, which is going to be 0. It's the easiest one. So if we put 0 into this expression, we're going to get 4 times 0 minus 8 divided by 2 times 0 plus 1. So that's what the function equals when we put in x equals 0. And we get 0 minus 8, which is -8, 0 plus 1, which is 1. So we find out that the value of the function when x equals 0 is -8. So we already have 1 point. Let's find another point. Let's do +1. That's an easy one for math too. So if we put 1 in for the x's, we're going to get 4 times 1 minus 8 divided by 2 times 1 plus 1. So that'll give us -4 divided by 3, -4/3. Okay, it was easy to find that value. Maybe it's not so easy to understand what -4/3 means since we're so rusty on fractions, but let's forget about that for a while. Let's do 2. If you put 2 in there, I'm going to stop writing out the math. You're going to have to just use your brain now. Okay, so you put 2 in here. I'm going to put 2 here. Then I'm going to put 2 here. It's going to be 4 times 2 minus 8. 4 times 2 minus 8. 4 times 2 is 8. 8 minus 8 is 0. Okay, so the top is going to be 0. Then I'm going to put 2 in the bottom. So I'm going to get 2 times 2, which is 4, plus 1, which is 5. That gives me, for a value of f of 2, I am going to get 0 divided by 5. Now you might think, wait a second, 0 divided by 5, 0 divided by 5 is 0. So does it matter that I found 5 for the denominator? No, it doesn't. So actually, you could have stopped when you found the value for the numerator because it was 0. You could have stopped there. You didn't really care what the denominator was. Okay? So the denominator is 5, which means the value for f of 2 is going to be 0. Okay. What about if I put x equals -1 in there? Then I'm going to have -1 times 4, which is -4. -4 minus 8, which is -12. So I got -12 on top. And then I put -1 in the bottom. I'm going to get -2 times -1, which is -2, plus 1, which is -1. So I get -1 on the bottom. So -12 divided by -1 is just 12. right? Okay. What about -2? If I put -2 in here, I'm going to get -2 times 4, which is -8, minus 8, which is -16. So I get -16 on top. And then on the bottom, I'm going to get -2 times 2, which is -4, plus 1, which is -3. -16 divided by -3 is +16 divided by +3. So it's just 16/3. Okay, again, we get an ugly fraction, okay, that maybe you don't know exactly the value for that, but that's okay. All right. Just to give you an idea what this is, -4/3, if you do it in your calculator, you'll see that it's -1.33. 16.3, 16 divided by 3, if you do it on your calculator, you'll see it is equal to 5.33. Okay. Now I have 5 coordinate pairs here, and I'm going to go ahead and graph these coordinate pairs on an XY coordinate system here. And I'll do it in blue. So the first point is 0, -8. I'm going to have to divide up my graph paper here into smaller increments so that I can fit this on here. So each one of these slashes is equal to 1. All right. Oops. Okay. All right. So my first point is going to be -2, 5.33. I'm going to mark it in blue. So -2 is right here, right? And 5.33 is 2, 4, 4, 5.33. It's about there. Okay? My next point is -1, 12. -1 is here. 12 is, let's see, 2, 4, 6, 8, 10, 12. Okay? And 0, 0 is going to be 0, -8. 0, -8, right there. 1, -1.33. That's going to be about there, right? Because that's -1 and 1.33. -1.33 is about there. And finally, 2, 0. Okay. All right. Now, if we start connecting these, we're going to see the beginning of our hyperbolas. Okay. Now, looking at this, I'm imagining that the rest of the hyperbola kind of looks like this. Just from knowing what hyperbolas look like. But we don't really know that yet, so I'm going to erase those, okay? All right. Now that I've graphed like this this part that's close to the origin, I'm going to graph some points that are farther away just to see what's happening farther away. So, for example, how about if I graph what's out here? I'm not going to graph every single point. Now that it looks like it's not going to change that much, I'm going to graph, let's do x = 6. That would be a good point, right? Then I'll do x = 10. Excuse me. 6 and 10. Maybe I'll try and point out here, this would be -6. -6, and maybe -10. Okay, let's try all those. So we'll do 6 first. If we do 6 first, let's look at our equation again. We'll put 6 in here. We'll do 4 times 6, which is 24, minus 8, which is 16. So the numerator is going to be 16. And then the denominator, let's see, it's going to be 2, 2 times 6, which is 12, plus 1, which is 13. 16 divided by 13. And then if I do 10, it's going to be 10 times 4, which is 40, minus 8, which is 32. And then we'll put 10 in the bottom. It'll be 2 times 10, which is 20, plus 1, which is 21. And then I'm going to put negative 6 in. If I put negative 6 in, it's going to be negative 24 minus 8, which is negative 32. And if I put negative 6 in the bottom, it's going to be 2 times negative 6, which is negative 12, plus 1, which is negative 11. And then negative 10, if we put negative 10 in here, it'd be 4 times negative 10, which is negative 40, minus 8, which is negative 48. And if we put negative 10 in the bottom, it's going to be 2 times negative 10, which is negative 20, plus 1, which is negative 19. Okay. Now I'm going to start graphing these points. 16 divided by 13, maybe you don't know exactly what that is in decimal, and let's say you're on the you're doing the test and you don't have your calculator. Well, it's obviously slightly more than 1, right? And to graph it, you don't really need to know exactly how big it is. It's slightly more than 1. So it's 6, comma, 1 something, okay? So I'm going to graph that. So it's 6 and a little bit more than 1. And then I've graphed it. 10, comma, 32 divided by 21. 32 divided by 21, you may not know exactly how much that is, but it's between 1 and 2, right? It's between 1 and 2, so it's about 1.5. So 10, comma, 1.5. 10, comma, 1.5. Now you see, just by graphing 2 more points, I've graphed pretty much one side of the hyperbola. And you want to make it rounded, okay? You don't want to make it just connecting each point with a line. You want to round it so that it looks like a curve, because it is a curve, okay? Now I'm going to graph the points negative 6, comma, negative 32 divided by negative 11. Negative 32 divided by negative 11 is actually a positive number, right? 32 divided by 11. Okay, it's about equal to 3, positive 3. It's a slightly less than 3. Okay, so it's negative 6, comma, slightly less than 3. Negative 6, comma, slightly less than 3. Could be right there. Oops. Okay, and then finally the last one, negative 10, comma, and then negative 48 divided by negative 19. That's a positive number, right? The two negative numbers dividing each other are going to give you a positive number. 48 divided by 19, that's about 50 divided by 20. Okay, 50 divided by 20 is about 2.5. So it's about positive 2.5. So negative 10, comma, positive 2.5, about right there. So now you can see that the curve is going to look kind of like that. Okay, and we already have a pretty good drawing of what the hyperbola should look like by using math that we learned like in about 7th or 8th grade, right? So you don't need advanced math to graph a hyperbola. What we're learning in advanced math is how to use advanced math concepts like intercepts and asymptotes and other things to maybe more quickly graph a hyperbola. Okay, so now I'm going to go to the next screen and we're going to do the same problem, except for now we're going to do it using asymptotes and intercepts, etc. Okay. Okay, so the first thing we're going to remember how to do is how to find the vertical asymptote. Okay, the vertical asymptote is the place where there's an illegal value of x. Okay, an illegal value of x normally happens when you divide by 0 or when you take the square root of a negative number. In either of those cases, that's an illegal value of x. Okay, so in this case, let's see. Is there either of those cases? Well, there's no square root, so there's not going to be a vertical asymptote because of the square root. There is, however, a division by a variable expression which has an x in it. So I can suspect that the vertical asymptote is going to occur because in the denominator here, we have an x in it. So does that denominator ever become an illegal value, which is 0? So what I'm going to do is I'm going to take the denominator, I'm going to set it equal to 0 to see if there's a solution to that equation. If there is, then that's an illegal value of x. So I'm going to do algebra now to figure out if there's a value of x which makes this true. So I'm going to subtract 1 from both sides. Then I'm going to get 2x equals negative 1. Then I'm going to divide 2 by both sides. And then I'm going to get x equals negative 1/2. And I just discovered that there is a value of x, which happens to be negative 1/2, that when I put it in to here, it makes it 0, which would cause an illegal division by 0. So my result here is that x equals negative 1/2 is an illegal value. So actually, when I say what's the vertical asymptote, I can write here x equals negative 1/2. By the way, do not write vertical asymptote equals negative 1/2. Vertical asymptote is a line. The equation for a line equals x equals negative 1/2. You have to have an x or a y or something in it to make it the equation of a line. You cannot write vertical asymptote is negative 1/2. Okay? All right, now let's do the horizontal asymptote. Now the tricky thing about the horizontal asymptote is although that it's the same concept as it's an imaginary dotted line which the function is going to approach in the horizontal direction, you don't get it using the same method. So the horizontal asymptote is like kind of a completely different method. The thing about the horizontal asymptote is the horizontal asymptote is the value that the y approaches, because it's a horizontal asymptote, we're talking about y now. It's the value that the function approaches from a y standpoint as you go far to the left or far to the right. Okay? So the easiest way to get the horizontal asymptote is to put a big number in for x, because when you are far to the right, x is a big number, right? Okay, so for horizontal asymptote, what we're going to do is we're going to put a big number in for x. So I'm going to put in, like, x is 1,000. So I'm going to get 4 times 1,000 minus 8 divided by 2 times 1,000 plus 1. Okay, and then if you look at that and you still don't kind of know what number that is, you can go ahead and do the math. So it's going to be 4,000 minus 8. Oh, 4,000 minus 8 is 3,992. And the denominator is 2,000 plus 1, which is 2,001. Okay, now if you still don't know what that is going to equal to, go ahead and use your phone calculator to figure out what it is. It's going to be something like, let me get out my calculator. It's going to be close to 2.99 or something like, or 1.99. So I'm going to 3,992 divided by 2,001. That gives me 1.995. Okay, guess what the horizontal asymptote is? It's 2. Okay? I'm not going to say that the horizontal asymptote is always going to be a whole number, but it's going to be a rational number. Okay? It's going to be a fraction. Sometimes that fraction is going to be a whole number. How do you know exactly what number it's going to be? Well, you just put in larger and larger numbers, and then it will become more obvious what that number is. Okay? Maybe another way you could do it is you could put in a big negative number in here, like negative 1,000, and we're going to get the same number out, or we're going to approach the same number. So why don't we do that? Negative 1,000, positive 1,000. So we're going to get here, we're going to get negative 4,008 divided by negative 1999. And then we're going to use the calculator to figure it out. Now, since you don't have the calculator on some exams, you're going to have to get used to this and figure out using your brain. So this is going to be 2.005. Now, do you see, I got one side, it's approaching 2.005. The other side is 1.995. So now maybe it's a little bit easier to see that the number in between those two is 2. Okay? So the horizontal asymptote is y equals 2. And again, you must put y equals. The horizontal asymptote is not 2. The horizontal asymptote is a line. The equation of the line is y equals 2. Okay. I'm going to draw these lines x equals negative 1/2 and y equals 2. I'm going to draw it here on my graph. And again, remember that I'm dividing up each one of these units into 2 so that our graph can fit better. Okay, so first I'm going to draw the vertical line, vertical asymptote x equals negative 1/2. X equals negative 1/2 would be, there's the x value, that's negative 1/2, and I'm going to draw a dotted line in orange to represent x equals negative 1/2. Okay? All right. Then I'm going to draw the horizontal asymptote, which is y equals 2. It turns out to be a vertical, I'm sorry, did I say horizontal last time? Last time, the orange line is obviously vertical. The green line is horizontal asymptote, right? Y equals 2. Okay? So now I've drawn both of the asymptotes. And now I can kind of imagine that I know what the hyperbola is going to look like. The hyperbola is either going to look like this, or it's going to look like this. We already know that from doing so many problems, right? But we won't draw it yet. We're going to use other clues to help us. Now, domain and range are quite easy to figure out as long as you already have figured out the asymptotes, because the asymptotes are basically the opposite of domain and range. The asymptote tells you the value that's invalid or illegal. The domain says the values that are valid. Okay? So, for example, the only trick is which one corresponds to which. Does the domain correspond to vertical asymptote or horizontal asymptote? Okay? Just remember, the domain is x and the range is y. They're both in the same alphabetical order. D comes before R, x comes before y, right? So the domain is all the values of x except for negative 1/2. We just do the opposite of the vertical asymptote. The range is all the values of y except for 2. We just do the opposite of the horizontal asymptote. So now we're done with domain and range. X-intercept and Y-intercept. Okay, X-intercept and Y-intercept, the way you find X-intercept and Y-intercept hasn't changed from the time that you were in 7th grade. In 7th grade, you learned that the X-intercept always has, it's a point. The X-intercept is a point. It's the point that where the graph intersects the X-axis. So it could be here, it could be here, it could be here, it could be here. What do these points have in common? Well, all these points have in common a y-coordinate of 0. Okay? So basically, we know that the x-intercept has a y-coordinate of 0. The y-intercept is just the opposite. The y-intercept, we know, has an x-coordinate of 0. Okay? We just need to figure out what the other coordinate is. All right. The y-intercept is easier, so we'll do that one first, okay? So y-intercept, we know that the x-coordinate is 0. If we know the x-coordinate is 0, why don't we take our equation, which is 4x minus 8 divided by 2x plus 1, 4x minus 8 divided by 2x plus 1. We're going to take our equation for the function, and what we're going to do is we're going to put x equals 0, because we know that the x-coordinate is 0, so that means x equals 0. So actually, f of 0 is equal to the y-intercept. Okay? So we're going to put 4 times 0 minus 8 divided by 2, 0 plus 1, and that gives us negative 8 divided by 1. So the answer for the y-intercept is equal to negative 8. Negative 8. Okay? So actually we can graph that point already. Let's graph that point. 0, comma, negative 8. 0, comma, negative 8. It's right there. Now let's find the x-intercept. The x-intercept has a y-coordinate of 0. So we can do exactly the same thing, except it's a little bit more tricky, the algebra. But for example, we could take the y value, which is here, and we could replace that with 0, because we know that the coordinate we're looking for the y-coordinate is 0. Now we just need to use algebra to figure out what the x value makes that true. And now I've seen a lot of people make terrible arithmetic and algebra mistakes in trying to figure out what x is. Okay? Let me show you what some people have tried to do. Some people have tried to get x out of the denominator, which is fine. And they multiply both sides by 2x plus 1. But when they do that, they do a combination of addition and multiplication, and they multiply both sides by 2x plus 1, and they say that 0 times 2x plus 1 is 1, or is 2x plus 1. They think that multiplying by 0 is the same thing as multiplying by 1, but it's not, of course, right? Multiplying by 0 gives you 0, right? So if I do that, which is fine, if I multiply 2x plus 1 times both sides, the left side is going to become 0, right? Then it gives me 0 equals 4x minus 8. And then you might think, oh my God, look at that. 4x minus 8, 4x minus 8. I just did a multiplication by the denominator, and I just discovered that the numerator is going to be 0. And that goes back to something we saw before. Remember, we saw 0 over 5, and we said, wait, 0 divided by 5, that's the same thing as 0. It doesn't matter what the denominator is. If the numerator is 0, you don't care what the denominator is. And that's exactly what's happening in this case. Look at this case. You have the numerator, which is 4x minus 8. And if you want to make both the top and the bottom together into 0, the top must be 0. So you don't really care about the 2x plus 1. All you care about is the 4x minus 8. So let's figure out what x value would make that true. So you're going to add 8 to both sides, and then you're going to get 4x equals 8. And then you divide 4 from both sides, and you get x equals 2, because 8 divided by 4 is 2. So the x-intercept turns out to be x equals 2. So let's mark that. Okay? Now that we've marked just those 2 points, we already know that the hyperbola must be this set and not this set, right? Because the blue points are in the 4th quadrant. So let's kind of connect these with a curve, a graceful curve. And then we know that the rest of the hyperbola needs to come close to the green and the orange asymptotes, but never touch, okay? And so if that side looks like that, then the other side must kind of be a reflection. It looks kind of like that, okay? Let's try to get 1 point on the left side so that we can draw it more precisely. So let's take a point like, let's take this point here. X equals negative 2. If we put x equals negative 2 in our equation, we'll put f of negative 2. We'll get we'll get 4 times negative 2 minus 8 divided by 2 times negative 2 plus 1. So that'll be negative 16 divided by negative 3, which is equal to 5.33, positive 5.33. That sounds familiar, right? Because we already calculated that on the last page. So when you have x equals 2, when you have x equals negative 2, the y value is going to be 5.33. So actually that's the point that we're going to use here. And now we can kind of draw the asymptote going through that point, or the graph going through that point. Okay? Oh, I forgot. We didn't fill in that the x-intercept turned out to be 2, so I'm going to put 2 there. Okay? So you can see that each step by itself is not difficult, but each step is almost completely different than the other. So you know, you need to remember how each one is different somehow. And for me, the easiest ways is to truly understand the meaning of each one. Like, for example, vertical asymptote. You need to understand that the vertical asymptote comes about because there are illegal values of x's. Why do you have an illegal value of x? 2 reasons. One is it could be a negative number inside the square root sign. Another possibility is that you're dividing by 0. In the case of hyperbolas, it's always because you're dividing by 0, but later we'll have vertical asymptotes for other reasons, okay? So that gives you a hint. Okay, so vertical asymptotes, you find those by figuring out when the denominator equals 0. So take the denominator, in this case it's 2x plus 1, set it equal to 0. Figure out what x should be, okay? What about horizontal asymptote? A horizontal asymptote, this green line here, the green line is the number that is approached by the blue function when you go way to the left or way to the right. When you go way to the left, x is equal to negative big number, like negative 1,000. When you go way to the right, the blue function, or the x value for the blue function goes to a positive big number, like x equals positive 1,000. So if you put the number positive 1,000 or negative 1,000 in for x, then you're going to get the value of the height of the horizontal asymptote. Okay? You're not going to get exactly the number, but you're going to get like 1.995, 2.005, and obviously between these two, the magic number is going to be 2. So then you can write that the horizontal asymptote is y equals 2. Now the domain is going to be the legal values of x. The vertical asymptote are the illegal values of x. So basically they're the opposite of each other. If you know that the vertical asymptote is x equals negative 1/2, then the domain is x is not equal to negative 1/2. Same thing with the range. The range is the opposite of the horizontal asymptote. So instead of y equals 2, you have y is not equal to 2. What about x-intercept? X-intercept is the coordinate pair on the graph where the y coordinate is 0. And the y-intercept is the coordinate pair where the x coordinate is 0. Okay, so how do you find the y-intercept? You take x equals 0, you put it in the equation, see what you get out for y. We get negative 8. How do you find the x-intercept? The x-intercept, you put 0 in for the y, and then you figure out what value of x makes that true. It's a little bit more difficult, a little bit more algebra. But once you have 0 here on the left, you know that only the top has to be 0, the bottom doesn't matter. So you just set 4x minus 8 equals 0. That will give you the x-intercept. Okay? And then I recommend that you do several of these problems. You can tell that, like, the first time you do this problem, look at this. I took probably about 20 minutes just to do this one here, or maybe 15 minutes. It's a long time. Okay? Now, rest assured, when you do the third or fourth one, it's not going to take you 15 minutes like the other ones. You're going to get used to it. You're going to be able to do a lot of stuff without writing it down after you get used to it. Okay? But don't feel like watching this video and understanding it is enough to be able to do one of these problems yourself. The only way to do this problem yourself, do these problems yourself, is to do several problems by yourself without any help. Without the help of a teacher, without the help of a video, without the help of an open book. Okay, you have to be able to do this problem without looking at anything. Okay, and of course, the first few times you do it, you're going to have a video. You're going to have a teacher. You're going to have an open example. You're going to have your notes. But eventually, you have to get to the point where you can do these problems without mistakes, with no help at all. Otherwise, how are you going to be able to do it on the test, right? So practice a lot of these problems. As you do the problems, take away your crutches, okay? Stop looking at your notes. Stop looking at, stop using the calculator. Stop asking questions to your friends. Eventually you get to the point where you do the whole problem all by yourself and you're confident that everything is correct because the repetition and your deepening knowledge is going to make it make sense, and you're going to recognize when you got the right procedures, because it all fits together, okay? Like when you get the wrong answer for something, you're going to see it on the graph. The graph isn't going to make sense. Your x-intercept and your y-intercepts are going to be in places that force you to cross the asymptote or other things, okay? All right, so this was a really long video, but that's what happens when we do a problem in slow motion, okay? Which is necessary sometimes, but I can't emphasize enough that you do need to do several of these problems. Okay? Thank you.